Hi, everyone. Thanks for joining us today, as well as my colleagues from West Virginia University and the Bridge Initiative. My name is Anthony Armley. I am the federal coordinator here at NETL based in Pittsburgh for the Regional Workforce Initiative. This is a focus on the Appalachian region where we connect with stakeholders consistently and try to engage on advancing technologies and workforce development initiatives. Next slide. So our mission here, again, we're focusing on, we're an extension of the NETL's mission, which is to get technologies to market. We're focusing on that Appalachian region where there's a lot of rich resources, in the ground, coal, oil, natural gas, and that aligns very well to a lot of our core competencies and technology thrusts here at the lab. We work really hard to support regional economic development and workforce development opportunities, and I think that aligns very well to what we'll be talking about today with some of these new, initiatives that WVU is working on. Next slide, Matt. One of the things that we try to do with this initiative that we kicked off in 2017 is to try to share our lab with the region. So we hold different webinars of different types, Energy 101 series, where we take a technical topic at the lab, introduce it at a high level, so folks in our region have a better understanding of what it is that we do, why is that important, opportunities for future workforce implications, et cetera. As you can see, these metrics started at 0. So we have nearly 1,500 plus in the past year or so that have registered to our webinar series, such as one we're hosting today. We do have a monthly e-note that we put out, which has a lot of different funding opportunity announcements, newsworthy type items coming out of our lab. In the chat here, I put the link. If you click that link to our Regional Workforce Initiative website, you can scroll about halfway down. You can see there's a button to opt in for that. And so one of the things we try to do with these webinars is to give a platform for our stakeholders in the region the ability to share information that aligns to our core competencies and technology thrusts. And what they'll talk about today with the carbon dioxide removal aligns very well to NETL. We're doing work with carbon capture and storage, direct air capture, and then of course carbon dioxide removal. So I'm really excited to hear more about the great work that WVU is doing and the Bridge Initiative. And I think our folks that are listening today will have a better understanding and interest in what it is that they're working on here and why it's important. So Matt, go forward here. So again, thanks again for joining us today. This webinar is recorded, so if you weren't able to make it or a colleague of yours might have an interest, we will be sharing this recording after the webinar, probably the next day or so. So be on the lookout for that. And I thank you for your participation. And Matt, back to you.
Okay, I'm going to turn it over to Joan.
Okay, thank you everybody for tuning into our webinar on carbon dioxide removal in West Virginia. This is a science and technology policy perspective. It's based on our policymaker guide that we developed over the past year and a half. Would you please go to the next slide, Debbie? I'm Joan Centrella. I'm the director of the Bridge Initiative at WVU. The Bridge Initiative works with faculty and staff researchers across all our campuses to translate the results of their research into policy alternatives and community opportunities to serve our land grant mission. Today, we're going to be hearing from Debbie Stein, who is a consultant to the Bridge Initiative, from our researcher Sam Taylor from the Energy Institute, and Professor Eddie Rostek from the Biology Department. So without further ado, let me turn it, and from Brooke Eastman, who is a Science Policy Fellow with us in the Bridge Initiative, and also an ecology and carbon researcher working with Eddie Rostek. So without further ado, Debbie, let me turn it over to you.
So Jen, you want to talk a little bit about the Bridge Initiative?
Oh, sure. I'd be happy to do that. So yes, the Bridge Initiative was started a little over 3 years ago at West Virginia University. And the reason we began this is because we have at West Virginia University, we have a very strong land grant mission. It means something deeply to us that the work we do at WVU, and we are an R1 institution, so we do a lot of research, that it matters to the community, it matters to West Virginia and beyond. How do we make that happen? How do we get this research out of the university into the community and into the hands of policymakers who can make decisions based on the knowledge we have. We work to translate in the Bridge Initiative, we work to translate that work into policymaker guides that can be used by policymakers and the general public to understand the research and its potential impact. Everything we do is based on peer-reviewed research. Everything in our policymaker guides is peer-reviewed and cited. And if you look at the QR code in the corner there, you can go to our website where you can find copies of not only our policymaker guides, but also the policy briefs. Okay.
Okay, so I'm going to give you an overview of the carbon dioxide removal report. So we first start out with a question. And the question we began with just about a year ago was, what actions, if any, should national, state, and local West Virginia policymakers take to enhance the removal and storage of CO2 from the atmosphere to reduce climate variation, increase economic opportunities, and create jobs for West Virginia? So our conclusion is that we believe that carbon dioxide removal has potential to bring economic growth to West Virginia. In case you are not aware of it already, CDR, as we'll talk about it from now on, removes CO2 already in the atmosphere, and it relies heavily on natural resources. And that's something that is in abundance in West Virginia. So there's 3 types of CDR. The first is natural, and West Virginia does have in the wetlands. Technologically enhanced CDR, which is such as bioenergy with carbon capture and storage. And in this case, we looked at it for both electricity and fuel production, and technological options such as direct air capture. So not only are the natural resources in West Virginia suited well for CDR, but also its geology. And so its ability to store CO2 in former oil and gas reservoirs, unminable coal seams, and saline formations makes it a really good place to look at for carbon dioxide removal. So what we did is we looked first at the West Virginia's natural carbon sequestration potential. So on the y-axis there, you'll see million metric tons of CO2 equivalent that can be removed annually by 2050. Existing sinks in terms of both forest and wetlands. And then you'll see here, based on what we know about how much we can reduce CO2 out of the atmosphere in forest management, agriculture management, abandoned mine land, reforestation, and wetlands restoration. And the goal here is to give a comparative analysis just to see how much potential there is with those resources. Then we did the same thing for BECCS, bioenergy with carbon capture and storage. The graph on the left is electricity, and you can see how much we could get from forestry and energy crops and residues, and also on the right by converting the bioenergy to liquid fuels. And then here is the direct air capture potential. So in this case, we are really focusing on the southern West Virginia, and as Sam will talk a little bit later as to why that is the case. And we're really thinking about where we might store that CO2. So this is our comparison where we sort of put everything together, including cost estimates. So you see here on the left are key findings and recommendations that we believe that it's possible to create carbon reduction opportunities in West Virginia, to restore that carbon into West Virginia's natural resources, while at the same time benefiting West Virginia's economic prosperity, creating jobs for West Virginians, opening opportunities, and still protecting West Virginia's ecology, conservation, economy, and environment, and then also nurturing West Virginia's disadvantaged communities. And you'll see on this chart here the potential carbon dioxide removal. And this is the information, the range that you saw in the previous charts. That is in the first column there. The second column gives the dollars per ton of CO2 equivalent. And these numbers are based on analysis done by Lawrence Livermore National Lab. And then you'll see here that the reason they decrease over time for, say, bioenergy and for direct air capture is there an assumption that they have made that that we'll learn more about the technology and therefore we'll be able to reduce the cost. And then we take those two numbers together, multiply them, and then we get a range of how much annual investment would result in $1 million of tons per year. $1 million per year, sorry. Okay, then we take those numbers, we put them into a model that predicts what the jobs would be and also the tax impact. So you'll see here an example for natural carbon sequestration. You'll see what the output is in millions of dollars, the jobs that would be created, and then the labor income that would result, as well as the total taxes. And then you'll see here the same thing for direct air capture, biomass to electricity, and then biomass to fuels spending. So all these estimates were put together by West Virginia's Bureau of Business and Economic Research, which does a lot of these analysis. So with that, I'm going to turn it over to Sam to start talking about direct air capture.
Okay, direct air capture, it's down in southern West Virginia. This Sam guy is supposed to talk about it.
Yeah, so I think we need to mute whoever just said Sam was going to talk about it.
Well, at least I'm going to take a shot at it.
Okay, go ahead.
So back out and go back in again. It's easy. I got everything.
Okay.
Right, bye.
Okay, so let me go back one slide here. There we go. Go ahead, Sam.
All right, folks. So yeah, this is a pretty conversant audience, and we won't go deep dive into what is DAC and what is carbon storage. This is an audience that's familiar with both of these kinds of things. And so the crux of this study for us here was to try to take a look at. We know there's a lot of interest right now around carbon storage in the state. Lots of different activity on point source capture. We've had some announcements with the BIL and the Infrastructure Acts and these kinds of things about carbon capture from natural gas power plants. There's been a lot of interest in hydrogen. And so what we were taking a look at here was, and this is kind of a philosophy from our perspective, is there's going to be a lot of demand for storage, we think, in the northern part of the state, the natural gas belt of the state. But what can we do to maybe drive activity and maybe make this a good fit for parts of the state that are maybe getting missed in some of these other activities? And so DAC provides an interesting theoretical opportunity to drive your economic impact and your investments to the place where you want it. So when we started looking at the DAC CO2 storage problem in West Virginia, so the number one there, and I think we can see that anywhere in West Virginia, further study is needed to validate CO2 storage locations. We have a pretty good idea that there are storage resources in the state, but the geology of West Virginia is complex and it can change quick. There's been lots of activity in the economic incentive piece. So, 45Q is the one most folks are aware of, but just things in carbon utilization and all that. So thinking about what the incentives are to de-risk DAC in particular, which is still pretty technologically new, and what do you have to do in the storage piece of that. Then there are a lot of the DAC projects are a little more straightforward. The carbon accounting for sequestered carbon in this case is relatively straightforward. You can measure the CO2 you're injecting, but that definitely hits some of the other technologies we're talking about today. And then again, the crux of why we're looking in southern West Virginia is to think about communities and community development type angles for projects like this, particularly in southern West Virginia. All right, Debbie, I think you're the one advancing stuff. There we go. Perfect. So the location matters. Again, for us, we targeted southern West Virginia in particular because of economic conditions in that part of the state, and because DAC allows us to site where we have storage, not necessarily where the point source emissions are. This also dovetails nicely with some other work we've got going. So we're partnered with Coalfield Development Corp on the Build Back Better Regional Challenge projects, which is all focused on redevelopment for us, redevelopment of former mine sites under our former mine lands to sustainable land project. And so this was sort of an early offshoot of some of that work to say, can we find, just as a notional siting study, locations that overlie storage that we believe in and have sufficient surface acreage to host a direct air capture facility. Go ahead, Debbie. The other thing we wanted to take a look at was, again, can we target this into the places where you need it? So if you, with this right here, this is the disadvantaged community. And I keep having to be careful with DAC because in this case, the acronym works for both disadvantaged community and direct air capture. And, using literature estimates, the small scale facility can generate 3,500 jobs. That's construction and operation. But again, if we're talking the southern coal fields, this is a chance to do large scale construction infrastructure type investing in a place where you want it. And again, as an economic developer, a lot of times it's tricky to get the impact in the place where you want it. And I mentioned earlier the activities in more northern West Virginia and the Kanawha Valley around hydrogen hubs and point source capture. That's the other wrinkle here, is that can we target storage locations that may be in less competition, both for surface acreage and for the pore space than are in the natural gas regions in northern West Virginia or near some of the larger coal-fired power plants and these kinds of things. Go ahead, Debbie. The other thing too is, again, for this audience, we have to get deep into, what is DAC, but it is energy intensive, and it can be a large physical footprint kind of. Someone's got the mute button out here. Anyways, so we understand you need large physical footprint, and so there's some other work that we're able to leverage here at WVU that's actually starting up right now, where, for example, a common technology pairing that you'll see for direct air capture is to do DAC with geothermal, for example, or to use the heat to regenerate and to regenerate the capture system. And this is some work we've got working at the same time here, where we're currently doing some exploratory drilling for geothermal resource that, in theory, could you pair with DAC to do a project like this in West Virginia? Good. And then what this all ties into then is, how do you protect and engage your local communities? So, again, we're targeting, some of these coalfield communities have had a lot of, pretty poor economic outcomes over the last decade, and trying to address, community concerns as we've been going through all these larger projects, that, jobs is a key piece of the discussion for a technology deployment like this, but it's not the only piece. And being able to address whether there are environmental impacts, are there direct impacts to, say, neighbors of the facility or thing like that? What do you have to talk about truck traffic and these kinds of things? So the community engagement piece, especially in places like this, is critical because they've heard it before. They've heard that this is going to be great. Just watch. And so being very direct and open about the conversation going in, what this is, what you expect the impacts to be, what you expect the economic impacts to be, becomes critical for a project like this. But overall, we think there are some legs here. I'm not sure if I missed it in the pass through there, Debbie, but we identified about 60 sites that look to have sufficient acreage, overlaying a sufficient storage reservoir. That's the punchline. And again, this needs a lot more scientific rigor to really hash out, but just on an initial siting screening in partnership with the West Virginia Geological Survey on our storage resource, there is something here. There's something to look at further. And so that's been some of my work here, is to try to, with commercial partners or with some of the other activities around the region, can we identify, partners that would maybe want to go to the dance with us on a project like this. So I'll check up there.
Okay, now we're switching over to Eddie.
Hello, everybody. So I'm going to talk about our natural CDR processes. And one of the things we're really focused on was forest carbon storage, because West Virginia has abundant forests. It's about 75% forest. It's the third most forested state in the US. And so we have a number of different recommendations. And one of the things we're really interested in is trying to get small family forest owners into carbon credit markets, because right now these markets are really dominated by larger landowners who tend to have these 3,000 to 4,000 acre tracts that small family forest owners just don't have the economies of scale to get into these markets. The second one we looked at was thinking about trying to get the forest products industry on board, because there are some concerns about if you put a substantial chunk of West Virginia forest into carbon credit markets, this could have an impact on the production of timber and forest products. And so we want to get their buy-in by getting them on board, getting them to get some of the benefits of carbon credit markets. And then the third thing we looked at was, a lot of the 45Q tax incentives are focused on technology-based CDR options. And we don't have a similar thing for nature-based CDR options, even though right now these are the most effective options we have in our toolkit. We know they work and we can make them work. And then finally, or actually I got two more. We also, similar to the DAC stuff, there's a lot of uncertainty in actually doing the accounting for these projects. There's a lot of uncertainty if these projects are actually leading to substantial carbon sequestration. Are they being oversold, undersold? The other thing in the forest carbon markets is that they tend to focus on above ground carbon storage and then neglect a lot of the fact that there is a lot of carbon below ground in soils. And then finally, the last recommendation we looked at was thinking about trying to allay some of these concerns from landowners, the forest products industries, and also our ecological partners, and thinking about how do we optimize harvest cycles in our forests in West Virginia so that we can get the best carbon credit bang for our buck, but also keep the forest products industry humming. Next slide, Debbie. All right, so in this first one, we're really looking at these family forest owners. There's only over 12 million acres of forest in West Virginia, and over half of that is owned by small family forest owners. And what they really want to do is be able to keep their forest in their family, keep the land, be able to pay their taxes, and keep it as a forest. And one of the things is that they can't really enter these markets because it takes a big investment to get your forest project into the market. And so there's been a number of different initiatives by folks like the American Family Forest Foundation and the Nature Conservancy to bring small family forest owners into the market by reducing those economies of scale. And the good thing is that most of these agreements still allow for folks to timber their property sustainably, but also get some funds for doing carbon offset projects. Next slide, please. And so one of the big concerns, as I talked about before, is that the forest products industry is concerned about how this will impact their ability to timber and harvest West Virginia sustainably. And what we need to do is think about ways we can incentivize them. They're the ones making these long-lived forest products, wood that goes into houses, furniture, other things. And they're not really seeing the benefit of these carbon credit markets. It goes to the landowner and it goes to the folks downstream. They're not seeing it in the midstream. Next slide, Debbie. And again, so for the right now, there isn't a tax incentive for nature-based carbon removal, even though it is it's the one that works. We know it works. It's already working on the grounds. And so we had a recommendation that we need to get a tax credit for nature-based carbon removal, similar to the 45Q tax credit for technology-based CDR. Next slide. All right, and so these two I think are really important. One is that there's been a lot of press lately about carbon credit projects and whether they actually lead to substantial carbon removal. And I think there needs to be an investment by DOE and USDA to find ways where we can do this accounting correctly, whether it's through targeted measurement campaigns, development of new models that include our state-of-the-art science. We need to really make sure that these carbon credits and natural ecosystems are verifiable and are actually there. And then the final one here is, again, we want to manage our forests so that we can get the best economic benefit from them and also the best ecological benefit from them. So how do we optimize timber harvest, forest products industry with also the carbon credit industry so that we can create the most jobs and have the most economically sustainable forestry in our state. And I think with that, I'm done.
Okay, great. Well, thanks. If anybody wants a copy of the policymaker guide, and then we also have related to it some policy briefs, just like one two-sided page that kind of provide overviews of the guide. And also Brooke worked on a science and technology note that explains how the carbon credit process worked. You can go to the website here or use this QR code to get copies of the report and all the policy briefs. And we hope you will take the time to do so. And so with that, we can turn it over for questions.
Great. Thank you for that informative briefing. So yes, so we're going to be using the chat function for this. So we have one question. Are there statistics showing potential CO2 uptake versus CO2 production in West Virginia? I'm wondering what the need and the potentials are.
So I think it's a Sam question.
Or at least I can talk about what we don't know. So there are the statistics on the production are out there, and we're aware of that. The uptake becomes again, it's tough to, and it's some of the reason for this study is like with the biological approaches, you have to talk about the new way you're going to manage these things so that you get improved carbon uptake. Same thing, with DAC, it's like it's a function of how big your storage is. The short version is, at least today, the scales are gigantic. And the uptake, that's part of why we're looking so holistically at these, various subjects. I'm trying to run the math in my head. The last real estimate I saw for West Virginia, just out of big point source type things, was 40 to 50 million tons CO2 emissions a year in large point source type things. And, so that kind of speaks to the scale of, solutions you've got to come up with, across the technology space. So yeah, we'll call it a tall climb, just to put a non-scientific number around that.
So you'd mentioned earlier a little bit about the utilization of forests and small families forests, but the necessity of leveraging some sort of carbon credit. Are there carbon credits in West Virginia, or is there a carbon credit market that this would play into, or is it something proposed?
So there are a number of projects in the state that are part of the California Air Regulatory Board. So I don't know the exact number off the top of my head, but I think it's in the $400 to $500 million of carbon credits have been issued in the state through the California Air Regulatory Board. And those projects, given how expensive they are to start, those are the ones that typically go to large landowning companies. But there's also a voluntary market. So companies like Amazon, Microsoft, Google are trying to offset their CO2 emissions in their companies. And so they're buying credits as well. And so one of the projects, the other project that's out there is the Family Forest Carbon Program that's run by the American Forest Foundation and the Nature Conservancy. And so they're working to get folks who may have anywhere from 40 to 100 acres involved in these projects. And they've really reduced the upfront investment by using some remote sensing and some other Forest Service data so that they don't have to do the detailed site-specific work that you would have to do for CARP. And so the idea is, can we expand on that Family Forest Carbon Program? Can we get more folks into that? Can we expand that across the state so that people can get into these markets? And if you're a small family forest owner in the southern part of the state, if you can get a couple extra $1,000, that's going to be really important to you holding onto your lands and keeping it as a forest.
Yeah, why don't we say, Brooke, do you have anything to add to what Eddie said?
No, I think you covered it. There's I guess just to summarize, there's maybe 3 or 4 programs right now in West Virginia that allows landowners to enter into the carbon market.
So, let's take a look at some of the questions that have come in. How many miles of CO2 pipeline are expected to be needed in West Virginia?
The good news about this study is we explicitly tried to avoid having to talk about that too much. So with the direct air capture conversation, you're trying to pick a location where you don't need much in the way of pipeline infrastructure, very short runs. Overall, this actually, to me, totally outside of this study, is one of the bigger concerns on CO2 in the state. I think that the answer to that is sort of as few as you can possibly get away with. Transfer the cost of construction, and in general, just public opposition and permitting costs and these kinds of things around pipeline construction in the Appalachians is a pretty tall challenge. So in all the folks we've been talking to, trying to optimize in your siting, in your early site selection, thinking about how to minimize pipeline build out is huge in our neighborhood, because just the cost of terrain here is so steep. So that's not a non-answer to how many miles, but the real answer is as few as you can possibly stand in terms of your economics.
So just to explain a bit further, maybe so you might remember that Sam mentioned there's like these 66 sites, right? So in southern West Virginia that are possible carbon storage locations. And so you can also think about them as that's where direct air capture might be. So again, we're focusing just on southern West Virginia. So the concept here is that, if you have, say, direct air capture and it might be, say, on abandoned mine land, then you would also have some sort of carbon storage option nearby. And all those things could all be linked together, ideally with renewable energy source, which is what you would need to do to make this a CO2 friendly activity. Is that right, Sam?
Okay. That's correct. And in our screening, we intentionally try to cite and find siting options to where the construction location or the DAC site is directly overlying 30 million tons of storage. That was our screening process, is do you have 30 million tons of storage with no pipeline built out other than just something across the facility itself?
So did you notice any key barriers to deploying CCS at industrial facilities? Is 485Q enough, and are our facilities taking advantage?
Well,
I mean,
yeah, I was about to say, I just want to mention that we intentionally did not look at CCS at industrial facilities. So this was basically, carbon dioxide reduction options that don't involve CCS. I'm sorry to interrupt you.
No, I was going to say more or less the same thing. In a broader regional discussion, I think there is a lot of interest, and I think some folks and facilities are, how to put this, they're investigating how to take advantage, I guess is the right answer. Some of the costs are high. We've been involved in several different commercial projects around the state, and that's been one of the bigger conversations, is just 45Q comes with a 12-year period, and from the time the equipment starts, and can you get break even in 12 years, these kinds of things. So I think we're just seeing the nascent ramp up in interest and starting to get built out from that, and 45Q really has kickstarted that discussion. Folks were sort of interested before, but now we're starting to see like real engineering work because of the increase in the incentives.
Okay, let's see what else we have here. Joan, you had answered a question. Have you looked into CO2 reutilization as an option?
Short answer, yes. Again, in the forest capture kind of concept, that's a CO2 utilization approach, right? At its core. We've been looking at more chemical utilization. Folks have been talking about enhanced oil recovery and things like that for a while. The biggest issue, I think there was lots of interest in that if you have high purity, high quality streams. It's a mass mismatch. Again, if you're, it's tough to think of any utilization process that starts to approach the scales of the emissions we have in the state. So I think it's still very interesting. Anything that makes you money is an interesting topic. If you're talking about CO2 utilization, it's just you have to be honest with folks about, it's not hundreds of millions of tons of utilization a year that we've got. We just don't have technology that is at that scale yet. But yeah, we've definitely looked at that, and we've got a lot of fundamental research looking at those topics too.
So you showed metrics on job growth. Can you talk about workforce training opportunities for folks interested in these types of jobs? And I believe that job metrics that you showed was probably from some sort of modeling, maybe.
Yeah, but I think
how you got that from
yes,
in-plan, probably.
Yeah, I think it's really talking about the workforce training opportunities for those jobs, and that's part of the Build Back Better grant. So maybe, Sam, this is a good chance for you to talk about that program that we're already working on.
Yeah, it's a nice piece of overlap there in the BBB. All of these kind of technology concepts, the reforestation, the soil work, and in technological capture is in bounds for us, and we're working with Coalfield Development Corp down in Wayne County on how you do training. Some of this is fairly linear in terms of it's earth moving, soil prep, outdoor labor type stuff, for reforestation. We're trying to get our hands around what it looks like to do training in a carbon centric, if you're handling supercritical CO2 and these kinds of things. It aligns a lot with our chemical processing industries in the southern part of the state. So it's a similar skill set, but it's some different materials. And, and trying to identify with labor, with workforce type folks, where the nuance has been a little bit of the key work here. Are there special handling things with supercritical CO2 versus insert whatever your process or product might be here. But yeah, there's going to be a lot of workforce training type opportunities, and we're trying to like both sides of it here with the the BBB, very focused on field deployment, workforce deployment of these kinds of technologies, and and then on our side is the more technological and scaling kind of approaches for the work. But yeah, it's a whole ecosystem of work we've got going right now.
And I think if I remember right, Sam, that grant is like 4 years. So we'll have 4 years to do all the training that would be useful. And that certainly, it's probably going to take us 4 years, just to kind of do the analysis for like where the CO2 might be stored, to look at, say, those 66 sites and so forth. So I think the workforce development piece was going to go, pretty well because of this Build Back Better grant.
Thanks. How are you going to quantify and document how much CO2 a specific existing forest can capture over a specific period of time?
So I think that one's up my wheelhouse. So there's an out of Sam's wheelhouse. So there's a number of different ways that folks do this. So one of them is you start off, you do a big forest inventory, and then you use that data to drive a forestry growth and yield model. And that growth and yield model will predict how much above ground carbon you will store, how harvesting over that time period will impact how much carbon you will store, because they run on this assumption that young forests are vigorously taking up CO2. And so if we keeping that forest in sort of that, in that area where it's still growing fast and taking up a lot of CO2, and then we're harvesting them, making long-lived forest products, they can quantify it through those models. One thing with those models is there's a lot of uncertainty. They run them out sometimes 40 to 100 years. And so you're looking at, what happens if the climate changes? What happens if CO2 levels keep going up? What are those actual numbers going to look like in the future? And so there's a lot of uncertainty in those modeling estimates. And so that's for some of the like bigger projects. For some of the smaller projects, what they're actually doing, what the Family Forest Carbon Program is doing, is the U.S. Forest Service has the Forest Inventory and Analysis Program, which is a series of plots located across most of the forested U.S. And so what they do is they'll pair a small forest owner's land with a plot that's very similar in the types of management and species. And then the Forest Service goes back and measures that every 5 years. And so they just pair them together, and they can use that as an analog for what your forest is doing so that you don't have to invest all that money into the measurements and modeling at a small site. And again, that's only the above ground. The below ground stuff is a really hard challenge. The agricultural sector is dealing with this. How do you measure increases in soil carbon over 5, over 10 years? It's really hard. So there's a lot of work looking at how do we measure and model soil carbon and above ground carbon across a number of different ecosystems, and it's a challenge still.
So biochar in agricultural use is large-scale opportunity in large agricultural communities. Is there an opportunity for biochar in West Virginia, especially perhaps related to biochar and flood mitigation? Biochar is a civil engineering option. Just brainstorming. So I guess, what do you guys know about biochar?
All right, so I know a little and not a lot.
Okay.
So there is some evidence that you can do biochar amendments into soils because that pyrogenic organic matter is really hard to break down. And so if you can get it in the soils, it locks that carbon in there for a very long time. There's also efforts to look at mixing basalt rocks into agricultural fields, that the basalt will actually mineralize CO2 while it's sitting in there. I think the one thing for West Virginia is that most of our agricultural land is in pasture and not predominantly in crop production. And so it's better for the state if we think about ways that we can enhance carbon storage in pasture lands through things like rotational grazing, introducing deep-rooted pasture grasses or grasses that are higher productivity or more resilient. So again, I don't know a lot about biochar, but there's a number of different solutions that folks are looking to in agriculture. And I don't know, Brooke, do you have anything to add on biochar?
I don't have a whole lot to add. I know that out west it's of a lot of interest because they have all this fuels that they're trying to get rid of for wildfire management. And so I know in like Colorado, for example, they're looking at using those fuels, converting from forests and converting them into biochar and using them to plug abandoned oil and gas wells as kind of a long-term carbon dioxide removal strategy. In West Virginia, we don't have as much of a concern about wildfires and that fuel buildup. And so I think one question for West Virginia in particular is kind of like where that biochar material would come from.
So does anyone else have a question? I think that was the last question that we had in the chat at the time.
Yeah, so Matt, can I talk a little bit more about the report, the policymaker guide development process a bit?
Sure.
Since I didn't want to spend too much time on it earlier. So I think one thing, this is our second policymaker guide. So the first one was on the waters of West Virginia, and we looked at issues, related to water recreation and water pollution and all sorts of, different things related to water, which of course is very important, flooding, infrastructure. This is our second guide that's on carbon dioxide removal, and then we'll be working, our third one will be on health-related issues. A key component in all these guides is stakeholder involvement, and I thought I'd mention it because I think it's so important for not this, but also I was talking to someone earlier today about the hydrogen hubs and so forth. So the way that we work is, we have about, say, 40 or 50 West Virginia University faculty and staff who work on our guides. They're then split up into different working groups. So for example, Eddie was the one on natural resources and Sam worked on technological resources. We also had somebody who worked on equity issues and somebody else who worked on ecology issues. So we focus on those different activities. Once we have a draft set of policy options, then we share those with stakeholder groups. So based on the different topics. So in this case, we had, like 3 or 4 different stakeholder roundtables. And the goal for these, and the faculty has been really good about this, is to kind of listen to what people say. So we provide them with the policy options and the findings, and then we ask them for feedback on those in the draft guide, and to prioritize them, looking at issues like effectiveness and cost effectiveness, economic efficiency, equity issues, and ease of acceptability. And based on those is how we make our final set of recommendations that I showed earlier in the day. I think everybody who works on both guides, would agree that these stakeholder roundtables are a really important part of the process, and make it so it's less of like an ivory tower kind of thing, because we are really bringing in these comments of, from the public, and definitely make substantive changes after all the different stakeholder roundtables. So I think that's just something really to keep in mind as these participatory activities are involved. It's a good model for other policymaker guides, so that we can speak with a lot of confidence when we talk to actual policymakers about the guides, and that, what the public thinks about what we're recommending.
Thanks for that background on how the sausage was made. So I think we don't. Oh, well, there's some question here. Sorry. It's a comment. So Deborah's comments bring to mind that Bridge Initiatives is to STEM as clinical transition work is medicine. Can you discuss potential careers related to translational work with communities and community acceptance? Do we have enough skilled workforce for the translational efforts?
Matt, I'd like to take that one. That's a great question. Careers, we are looking to build policy fellowships. We've already have a small pilot program for PhD students, master's and PhD students here at WVU, who are learning to be policy fellows and write policy briefs. And so we're hoping to build that career pipeline. But it's a new field. I mean, we do have nationwide, there are policy fellowships. AAAS has them, several states have them. We'd like to build a program like that in West Virginia, and we're working on that. As far as do we have a skilled workforce? Well, we're working on that too. And all the people who come through our studies learn how to hands-on work with translating their work into policy options through participating in the process. We also have a Bridge Faculty Fellows program. We're just finishing off our second cohort, and we've just advertised we're going to be selecting in the next couple of weeks our third cohort of faculty members who bring their own research. It's a variety of different topics. Eddie actually was one of our initial policy fellows, and they work with our team, mentored and led by Debbie, over the course of a year, and they learn how to bring their own skills into doing this. And I would say, I'm going to speak for Eddie and say that it was very, very effective. Eddie went down to the legislature this winter and spoke with them, did some discussion with the legislature on the topics of forest carbon. And Brooke Eastman is the policy fellow. Actually, we've had funding over the past year for Brooke Eastman, who is a PhD. Gosh, it's been almost a year since she got her PhD. And so she is an early career person actively out in this field. From what I can tell, from the interest we have in our programs, there is greater demand at WVU for this kind of training, and we're hoping to continue building that up. I don't know if Brooke or Eddie would like to say anything about their experiences.
Yeah.
I was gonna let Brooke go.
Yeah, I'll share that, like me, and there's a lot of other grad students who volunteer also for Bridge too. There's a lot of interest in making an impact with your research, especially in younger scientists. And so I think it's kind of like Joan said, it's in the initial stages, but there's a lot of momentum behind it. There's a lot of interest. And one thing that I'm hoping to focus on in the next year is kind of creating a network across the university and beyond of scientists that are interested in translating their research with the public. So hopefully grow and build that effort.
Yeah. and working down with the communities. And that's that Brooke is our lead on that. And actually getting into the communities. We have partners, especially through the Build Back Better group. We have Coalfields and we have the West Virginia Community Hub. And we're in the early stages of working with them so that we can, so far we've been working across the campus and presenting, working, building relationships with the policymakers. A key part of this, which we're in the early stages of, is building those relationships with the communities. And we're moving towards the model, the gold standard model, in which we don't just tell them what we think the problems are. We begin by working with the communities and having them tell us what their concerns are and what their priorities are, a co-creation model. And we're just starting out just in the very early stages of our public health study, and we're committed to a full co-creation model on that. But it is a process. We're learning along with everybody else.
I do want to mention something about community benefit agreements, but Eddie, did you want to talk at all about your faculty fellow experience?
Sure, I can give a quick one since we're running out of time. But for me, I think it was really valuable to move from making science that just went to my peers and being able to find outlets where you could actually integrate with and interface with folks in the public, whether it was through talks with, community groups or going down to the State House, or we also do a number of events with K-12 students. I think just getting your science out of your office, out of your lab is really important. And that was really the big thing I valued working with the Bridge.
Yeah, I just wanted to talk, just a little bit, sorry, Matt, about community benefit agreements. So this is something that we're starting to see a lot of requirements or, need for activities with the community as part of grants. And it's, and a lot of what we did in this policymaker guide was, equity analysis, trying to kind of set the basis for those activities. So I think the bottom line is, do we have enough skilled people to do this today? I would say not yet, because it's a burgeoning field, but I will say that we have a lot of information from the side of equity analysis that can help us with those in terms of like what works and doesn't work in interacting with communities, and we just need to build upon those as we develop this workforce for the future.
So I just wanted to make sure that we got a chance to mention everything that's been said. There was a comment in the Q&A thing that the WebEx has, and I hadn't seen it till now. If you locate DAC in southern West Virginia, you will not capture max CO2 that is in the upper Ohio Valley. That's one comment. And then another question that just came in, this will probably be the last question. Are most of the emitting points in West Virginia, is in the western portion of West Virginia?
Ben Cross and I are having just a one-on-one discussion in the chat there. So
just want to make sure everybody's comments get
yeah. It's basically we were just talking about, I'd mentioned earlier that there were 50 million tons, and the top 12 emitters get you more than 50 million tons in 2020. And most of those sources are, central western-ish West Virginia, with a few notable exceptions. Mount Storm, it has some pretty complex geology in that neighborhood, and there's some large industrial emitters in the eastern panhandle and the eastern part of the state that are a bit challenging. But yeah, the good news is most of the large emitters are at least in places where we think there should be storage. So that's the good news.
Great. So we just have a little bit of time. Anthony, Debbie, or anybody else that has some parting words, let's maybe get through that, and then we will call it an afternoon.
Yeah, I'll jump in here.
Great stuff.
Yes, absolutely. And first of all, great discussion today. I appreciate all the comments coming in through the Q&A and the chat. This is what we want it to be, is an engaging opportunity to have a great discussion on some of this work. And so I would like to say, if anybody else listening today has an interest in utilizing NETL RWFI's platform in the future for a webinar similar to this, please reach out to Matt or I, and we'd be happy to chat with you further. I think this is a great example of a success. that you can have, having the ability to share information with a wide range of people interested. So thank you again to everyone from West Virginia today. Really appreciate it, and it was great discussion.
Yeah, and I just wanted to, thank everybody for attending. I did put in the chat the Bridge website. So, feel free to go there and see all the policymaker guides and so forth. And I think the recording's going to be available in a few days, and we'll put that on the website as well as the slides that we just showed you guys.
Great. Yeah. So that's correct. And I think we got through everybody's questions. And so
I just see that Brooke and I both simultaneously, Brooke put the website, I just put in our general email. You are all welcome to Google us and find our emails and contact us directly, especially if you have specific questions, go right ahead. If you have general questions, you can send them to sci-tech-policy@mail.wvu.edu.
Great, thank you so much.
Yeah, thanks. I think we've Anthony, you've shared our website. If you're interested in other events like this or webinars or things coming up, we do have a something of a newsletter that we send out through email called the eNote. And so please make sure to sign up for that at the website. And if there's any other words, or we're ready to close it out.
Thanks, everyone.
Awesome. Thanks, everyone.
Thanks, everybody. Have a nice afternoon.